We are at the closing party of Code It, and actually, first of all, let me guide you through today's schedule. So first of all, we are having a short intro with me. After that, we have a keynote speaker, Tony Strandl from Reactor, giving a keynote speech for about 30 minutes. After that, we have obviously our award ceremony, because these prizes are here to be awarded to someone. Then we have a short editorial session where the best hackers will share some of their approaches to our toughest challenges. And after that, we're actually here to network and to have parties. And during Code It contest, we were able to have 2 separate events, and we were able to attract 46 participants, and believe me, we had a lot of submissions for that. So what I want to especially point out is that today, just remember that today is a winner's day. So today there are no losers, and every active participant will get this glorious hat from Reactor and this t-shirt. So just check it out. And Olga, where are you? Just raise your hand. Yeah, Olga is responsible for it, so just approach her and ask for your prizes. And we are happy to attract so many passionate hackers, and we really hope you enjoyed it. And speaking about passionate hackers, let's give a big hand to Tony Strandl from Reactor.
Hello, everybody. I'm Tony Strandl, as said, from Reactor, and I came to talk to you about culture of hacking. Now, just to get the official part out of the way, Reactor is a company of a bunch of passionate IT professionals. I'm there mostly doing front-end development, UI design, and guiding people through their projects and life. By the way, if you're looking for a Jamo job, we're hiring, so you might want to check us out. But I didn't come here to talk about Reactor. I came here because you had this Code It event. Now, I was offered a chance to come to talk here. And when I went to your site and look at what Code It is about, it's a programming contest. You have like 9 days to code. You code every day a bit, and then you compete against each other. I thought that was so inspiring and so great that I just didn't want to miss this event. So I was really excited to come here. And sort of everything that I'm now going to present is inspired by this event. So this is not the presentation that I've given anywhere else before. But to start, I want to tell you a bit what I'm going to talk about. So I'm not going to go into the history of hacking and how the term is defined and what it's about and that sort of stuff. I'm not going to present classic hacks or practical jokes or pigeons delivering messages between some Linux boxes. I'm also not going to talk about hacking into systems or cracking. If you had a chance to be at the last year's Reactor Dev Day conference, Kevin Mitnick was there talking about this, and I think he's much more convincing than I could be. But I'm going to talk about hacking, sort of hacking and me, how I see hacking, what I consider is sort of hacking, how I think the hacking mindset can benefit us, not in just computer science or solving technical or software problems, but sort of in a more general way. Now, because now it's a bit difficult to know what hacking is, so let's define some terms. So I bumped into this definition of hacking. It says that hacking can be considered as an appropriate application of ingenuity. An appropriate application of ingenuity. I think even those words sound like a hack. It tastes good in your mouth, in a way. It's also great because it leaves open the sort of definition what a hack is. It sort of gives you the idea what it's made about. But it can be either something very sort of quick and dirty, just a quick hack, just to get something done. Or it can be something like a real piece of art, like something so carefully crafted. And both of those are sort of hacks. And no matter which one it is, you just have to admire the cleverness that went into it. So I think that sort of defines what a hack is. You just look at the result and you're like, wow, that's so cool. I think you guys probably have at some point during this event, if you've been participating in the coding competitions, you've done something that you consider a hack, or maybe you hacked together the whole thing. At least I hope so, because that's sort of great feeling. It's like you beat the system. Now, what I think what hacking is about, It's about bending the rules. Now, some people might consider that it's not fair, but of course it is, because it's a hack. That's the whole point. It's about cutting corners to get to some results faster. It's about creativity, to find new solutions to stuff that has been solved somehow differently, or find something new altogether. Now, let's go into some examples. One thing that I consider a hack is probably the best piece of news from last year that I've read. I don't read too much news because I think those are, pretty disturbing mostly, but this was a really nice piece of news. So there's this crazy speculative market of debt in the US. So banks loan money to people, and if the person can't pay it back, then the debt goes bad, and it's worthless to the bank. So there's this gray market, or it feels like gray market of debt in the US, where banks sell debt for pennies on the dollar. So for example, with $100, you can buy debt for $5,000, and then you can try to collect it. And even if you get only 200, or you get only some of the loans, you have like 10 loans and you can only collect one, then you can still win something. And that sort of sounds, that sounds sketchy. That sounds sort of very capitalistic and very bad. But there was this group of like-minded people, and they sort of figure out the rules of the system. They started collecting donations, and they actually collected something a little less than $700,000. And what they used the money for is that they bought medical debt worth of almost $15 million. And instead of collecting it, they just canceled it. Like, boom, $50 million just sort of vanished from the world. And the people who had to take the loan to be able to, go to dentist or whatever, they just were given this pardonment, like, you no longer owe us money, so feel free to continue your life. So they used the rules of the system against the system itself. I think that was pretty brilliant. And if that's not an appropriate application of ingenuity, I don't know what it is. So this was Rolling Jubilee, a sort of part of the American movement now that the 99% are trying to make sort of the living out of the world, because well, that was in my mind the best news from last year, and a great hack. Another example is this guy. His name is Logan LaPlante. He's 13 years old. He's giving a presentation in a TEDx event, and he's talking about his education. Now, he starts the talk by saying that adults often ask from kids that, what do you want to be when you grow up? And then they expect to hear like an astronaut or a police or a fireman or some other fancy thing. Now, instead, when Logan was asked that, what do you want to be when you grow up? He said, I want to be happy. I want to be happy and healthy. Now, that sort of makes sense. It's pretty difficult to disagree on that. Everybody wants to be happy. But then he goes on to ask that if sort of being happy and healthy is a priority for people, then why it's not a priority in schools? Why are we not taught how to be happy and healthy? He puts it in a great way, I think. He says that education is oriented towards making a living instead of making a life. Now, that sort of sums it up. Education is about learning stuff so that you can get a job, so that you can earn money, so that you can pay taxes and buy a house, and then make kids, I guess. And then you grow those up so that they can go to school and keep the thing rolling. School kills creativity, he said. Now, when he sort of arrived in this conclusion, what he did is that he hacked his education. That's how he said. He calls it hack schooling. So together with his parents, they took him out of normal school, and he started homeschooling. He started, instead of sort of memorizing stuff, he started experimenting. He studied history in a way which sort of sounds pretty good. So instead of just memorizing stuff from the history, he learned some character he sort of did what people do in theaters. You learn about some characters so well that you can play them on stage. So that's what he did. He played historical characters on stage. And in that way, you have to be pretty deep in the character's life so that you can confidently play them on stage. He also hated writing in school. He said that I had to write about butterflies and stuff, not very interesting. But then on his own, when he started writing, he wrote about stuff that interested him, like skiing, for example. He was pretty enthusiastic downhill skier. And then he published his writings in local papers and the internet. And that sort of felt good for him. Now he's a pretty enthusiastic writer as well. So he thinks that the school is not set up correctly for people to experience life. He said that, I'm not afraid to look for shortcuts for better and faster results. I think that's sort of the hacking mindset. He says that I never lose sight of keeping happy and healthy a priority. It sounds so obvious. Shouldn't school be that way? It sounds so simple. And I think that's also how hacking is defined. It's presenting something simple, something obvious, something when you see it, you just realize that, that's the way it should be. But also very true to hacking and hacks is that getting to simple is really hard at sometimes. You often need to break the norm. You can't go by the norm, how things used to be. You can't go by people's expectations. You have to do something you believe in, because otherwise you're not getting to simple. Then you're just getting somewhere that's already defined. Now, these were some examples from outside our sort of field of profession. But let's get back to software. And something that's often not considered so simple is software development. And for example, software development processes. So software development is so difficult that we have to come up with processes so that we actually know how to do the stuff. Or at least that's what we've done. I don't know, is it really that difficult, but that's what we have ended up with. Now, there's this dude called Jed Shaw. He writes articles on the internet. He's a hacker, a software developer. He's a pretty angry dude, and he writes pretty sort of strong opinions on stuff. And he uses a lot of curse words. So when he thought about how software is done, he thought that all the processes are crap. I can do better. So he wrote a new software development methodology called programming motherfucker. So in that one, he says that we need to focus on the one thing that brings software to life, and that's programming. Let's see what it's about. So first, you write out a list of shit to do, and then he says that using software, which I think is overrated, you just need to know what you're doing. Then you do some of that shit using programming, and then you test if that shit's any good. If it's not, you go fix it with programming. You run this in a while loop until it's done. Now, it sounds like it sort of doesn't make too much sense. It sounds like just curse words. But when you actually think about it, if you know what you're doing, number one, you do some of that. Number two, and then you see if it's good. Number three, if it's good, then you're succeeded. This is pretty much all you need to do good software. Now, number one and number three are actually pretty difficult. Again, this is simple. It sounds simple. It sounds obvious. This is the way it is. But to get this done, to sort of be successful with this, it's not so easy. And of course, even Jed Shaw realized that it's not quite that simple. So to help with programming, motherfucker, you need some management, of course. So management is there to help you figuring out what you need to do, and what you have done, they tell you if it's good or not. So the role of management is all about making sure that programming is allowed to happen. Now, I think there's a gem hidden inside that. Management should help you to be able to program. Making sure that it's allowed to happen Now, that's a great way to think about management. I'm not saying that managers are waste, but I think this is the actual role of management. A real leader, he makes the environment so that every good thing is allowed to happen. I'll show you another thing as well. It has some of the same simplicity built in as this one. As it says, it's a motherfucking website. So again, it sounds pretty harsh, but it's actually ranked against the current one-page application responsive web design theme that we've been seeing last years. So what it says that it's very lightweight. It's responsive as the web is by definition. Most of the problems that we have, that we now try to fix with media queries or other stuff, we create those problems ourselves. The web by design, it works. It's responsive. This is what he says about cross-browser compatibility. It just works. It's already there. We make it complicated instead of making it simple, what we should be doing. It's easy to make things complicated. It's very easy. Everybody can do that. But to make things simple, you need to work hard. Now, to be fair, I'm going to show you something that I've been hacking as well. I'm not going to go into the code. It's going to look like, it would look like how you would expect, magic numbers and stuff. But in Reactor, we have these coding camps as well. So every year we go with a bunch of colleagues to some remote isolated location, and then we hack away for 2 or 3 days. And usually there's some kind of theme. Last year, we were given this platform where mobile devices worked as sort of controllers. It had a tilt sensor and 2 buttons. And the job was to create a multiplayer game. So people could join, they could control it with their devices, and you could figure out what kind of game you would like to build. So my team, 4 people, we created Pants of Elvis. Now, Pants of Elvis, this is the end result of our game. So we started by doing a sort of spaceship type of fly and shoot, try to achieve something kind of game. So here you have sort of vessels that you can control with the device, and then you have 2 buttons there. One is throttle, so if you want to move forward, you have to press the one button, and then the other one is for shooting. And you had 2 different goals. You could either kill everybody else and then win, or you could land in the pants and win. So that's sort of the platform. And when run, the game looked like something like this. So you could shoot other people, and then your job was to land there or kill everybody else. So first we just had some of the basic movement, so you could just move around, and first we didn't have shooting, so you could just poke others, and we didn't even have a goal. The game didn't end at all. And in the next version, we had the platform where you were supposed to land, and the one who landed first won. In the third version, you could shoot, and then we bumped into this sort of thing of physics. So our ammo was so sort of powerful that it was impossible to try to fly it because everybody was just bumping around the screen. In the fourth version, we actually put some definition of life. So everybody had like 10 life points. And when you lost those points, you died. So this is sort of iterative development as well. But I think most of the part we just spent tuning on the magic numbers to get the physics somehow right. It was actually pretty simple. But it was a complete hack. The end result, it was done so that the game is a web page. We had our JavaScript code inside the HTML. We had mostly just magic numbers and sort of code that you couldn't figure out afterwards what it was. So I think it was a good hack, and it was a lot of fun. I have one more thing to tell you about. Do you know who this guy is? He's Giorgio Moroder. Now, he's often considered to be the guy who started who studied pioneered synth disco and electronic dance music. I think this picture is from the 70s or so. Pretty cool looking guy. True hipster, I guess. Last year, Daft Punk made a song called Giorgio by Moroder. And in that song, Giorgio spends a few minutes telling about his history, how he got into playing music, how he had to sleep in a car to be able to play music in some small village somewhere. He tells that he just knew that he didn't only want to play music, but also compose music. And he says that he was composing music, and he knew that he needed a song of the 60s, a sound of the 60s, a sound of the 70s, and a sound of the future. He just knew that he needed a click, and then they put the click in one of the songs. And that sort of, everybody were mind blown, and electronic dance music wasn't the same after that. But there was one thing in particular what he said that really caught my ear. He said that if you let go of the concept of harmony and music being correct, you can do whatever you want. And this is sort of what I consider the hacking mindset. I started thinking about this, and I sort of generalized it to apply to my field. So I thought that often people rant about JavaScript not being not so nice language to work in. It doesn't have types, and it's sort of just a mess. But if you consider it that way, if you let go of the concept of harmony and JavaScript being correct, you can do whatever you want. Pretty nice way of you looking at stuff. And you can generalize it to code in general, or even life. So if you let go of the concept of harmony and life being correct, even that sentence is not properly English, but I think that even makes it even nicer. You can do whatever you want. So I read this so that if you stop living based on other people's expectations, if you're not afraid to break the norm, you can do whatever you want. I think that's what hacking is about. So live your life doing what you enjoy and be happy. Thanks.
Now it's time to award the winners. And without further ado, I hope you're all present. Third place goes to Jasujm. So here it is. Yep. And congrats.
Thank you.
Congrats. For this, yeah, please stand here. We would like to have a photo with you, with all three of us. Thanks. And actually, the second place goes to King Greedy. Let's just applause to him, because he is not here. He's not, just less applause. Unfortunately, he's not here, and this is truly, I respect these guys so much, because what actually happened this day, he typed he's in Oulu, so he just can't come here, because he was coding until the very end of the contest. He was able to climb to the top 3 only in the very end today, so he was not able to come here. So let's applaud him once again. And the first place goes to Epicwu. So congrats.
Thank you.
Yeah. Yeah. Cool. Yeah, so please sit down. And now it's time for our short editorial session. So first of all, we have Nicholas Jern, who will guide us through his ultimate tic-tac-toe bot. Nicholas, come on stage.
Hello everyone, I'm going to give you a short walkthrough of what I did for the tic-tac-toe bot challenge. So this really has 2 parts, Monty, Randy. Tools used during the competition, pretty much here's what you have. Why did I go with Go? How many are familiar with Go here? It's kind of a new language, low-level systems programming language from Google. It's a lot of fun. You should try it. So the challenge, there are a lot of games, a lot of variations you can play of tic-tac-toe or ultimate tic-tac-toe. So I quickly calculated that somewhere around 8.8 sexdecillion, which if you convert it, this is actually the wrong version, I think. Well, we'll make do. So if you would have 16 gigabyte USB sticks, you would need 21 million billion trucks to transport those sticks if you want to use those sticks to represent all the possible games of Ultimate Tic-Tac-Toe that you could play. So there's a lot of games. Now the AI is going to have a limited execution time. So for most languages, or for most of the low-level languages, it was somewhere around 2 seconds. Go actually got 6 seconds, so that was a nice plus. And then you can only upload the code, so there's no training data. You can't run your bot and have it do machine learning on your own machine for a week before. It has to be smart from the beginning. So I went with a Monte Carlo search tree bot. How many use this technique in their own bots? Raise your hands. No? I'm the only one? Okay. So a Monte Carlo search tree basically means that when it's my turn, my bot takes a look at all the possible moves that it could make, and then it runs that game through till the end. And then if it wins, you know, that's probably a good path. If it loses, that's probably a bad path. And it kind of looks over all these alternatives, and then it just picks the one that's most likely to lead to a win. And it's very stupid in the beginning, because as I said, when you start the game, you can have something like 8.8 sexdecillion games. But when you get close to the end of the game, the bot has time to simulate almost all the possible routes the game can go. So it gets really smart towards the end. When it plays against a random bot, the bot just making random moves, it wins 100% of the time. When I had it playing against itself, it usually ties 80% of the time. Then this 13 and 7 is actually, when it's player 1, it wins 13% of the time. When it's player 2, it wins 7% of the time, because making the first move gives you a distinct advantage in this game. And so this improves also linearly with execution time. So the longer you have time to compute these possible games, what might happen, the better it's going to do at picking the right way forward. I decided to pick a language based on speed and also looking at the execution time that HackerRank gives you. So HackerRank has this page, environments, where they have a list of all their supported languages and the restrictions that apply to each language. So in my day job, I use a lot of Python. I use some C. I don't have to do a lot of Java. I'm thankful for that. But I'm familiar with all these languages, so I took a look. And you know, C, C++, it's very fast, but you only get 2 seconds of execution time on HackerRank, and that's not a lot. Python, very slow. You would get 16 seconds, but still I did some initial tests. It's not fast enough. Java is fast, but when you're warming up the JVM, it kind of eats into those 5 seconds you get. And Golang, for some reason, they give you 6 seconds for a compiled binary, and Golang is really fast. So that's really the main reason I decided to go with Go for this challenge. Then ruthlessly benchmark and optimize. So I did a lot of micro-optimization here, like Ville says you shouldn't, but sometimes you should. So the slowest function is checking which moves are available when you simulate these thousands and thousands of games. So I benchmarked. Go has great tools for that, and took this slowest function down from 15,000 nanoseconds to 4,000 nanoseconds, which means the bot can simulate something like 3,000 complete games from start to finish for every second, which is pretty good. And then the solution to the third problem, not being able to upload data, so this was something I was going to do, didn't have time. So start saving these successful search trees and then start using case-based reasoning when playing against the opponents on HackerRank, because you can actually write the files. Unfortunately, didn't have time to do this. Would have been fun. And using this real game history would have been a lot more realistic than just simulating random games ahead. So maybe I'll do it as a spare time project. Now, I just had some quick thoughts about this event. I thought it was really a lot of fun, and it was really nerve-wracking. 20 minutes before 5, I was still in the lead. And then 3 or 4 guys ran past me in the end. So congrats, guys. Good work. Would love to participate again, so I hope you do this event again. And I thought it was a good mix of algorithmic and more dynamic challenges. It's a good reason to just really sit down and learn some new algorithms, learn some new techniques. So these are just a few of the ones that I tried out for the first time for this challenge. I think the most interesting one was probability mapping, and MCST a close second. But that's it, so thanks. Hope to see you again next Code It.
Hi. Okay, now it's time for Battleship, the game which I won. The rules is very simple. You are given a 10 multiply 10 chessboard, and there are seven ships is hidden in this chessboard, and you must hit all of them. So the simplest idea for this game is just random hitting, but you need to pay more than 80 times to hit all of those ships in average. So we must have some better idea for this. The first idea is walk through. When you hit one ship, it's, the best choice is to detection the whole ship, destroy it. Because the more information you got, the more things you can do in the future. So I think everyone thought this idea. And even this simple improvement, you can finish the game under 70 times in average. So yeah, but what can we do? Can we do it better? The second idea is use probability density function. The idea is also simple. It's just enumerate all possible ship distribution solutions for this game. Yeah, so for clever AI, you will hit the one in the center of the chessboard for the first hit, because it has the largest possibility. And with the more information you got, the hidden information, the more information you know for the future game. But the performance of this method is still about 40 times. So if there are enough test cases, the expected score you got will be 12 points for each game, so 60 points in total. But in this game, I got 82 points. That's why I can rank first in the last 30 minutes. So is it possible? In fact, there are no much better way than probability density function. But yeah, here I just do some hack things. I just hack the game itself, because let's review the rule of the competition. First, there is no limit on the submit times. Second, I saw there are only 5 test cases for this Battleship game, and you know one. So there are only 4 unknown test cases. And the third rule is you will go to the test result firstly. So what I did is you can detect, you can calculate all the test cases with enough submit times. For first, look at this chessboard. You can hit all those white cells in the first submit. And if I detect destroyed, then I do some loop to make it time limit exist. Or I do it in a normal way, finish the game. So with the return result, I will know that whether there is a submarine in white grid. If it is time limit exists, then there must be one. So then I use binary search, just hit half of the chessboard. So you will So you will know the accurate position of the submarine with several submarines. And in fact, after test, I found there is no submarines in all test cases. And you can apply the same way to detect all the ships. So this is the first test case. Then with those information, you can do whatever. I think the King really applied the same ideas because finally he got 76 points, but he didn't know that I have got the result 2 days ago. And I tried to submit it in last 30 minutes because I don't want you guys to know it. Then when I submit, there's only 30 minutes left. You have no time to submit all those test cases. That's all, thank you. If it's one kind of cheat, please forgive me.
Today's official part has come to an end. So I congratulate all of you guys because I really hope you got a lot of experience in a competitive environment. You had a chance to meet great, interesting people here and to listen to amazing speakers. I really hope to see you again in our future events. And now we have our pizzas and party in the main stage. Thanks a lot and see you.